Not all quadratic equations can be solved by factoring. This is because not all quadratic expressions, ax squared plus bx plus c, are factorable. Some quadratic equations or functions cannot be solved by either extracting the square roots or factoring. So another method you can use to solve a quadratic equation or function is completing the square. We will now discuss solving quadratic equations or functions by completing the square. Example, f of x is equal to x squared plus 10x minus 11. Our first step is to change f of x to 0. So x squared plus 10x minus 11 equals 0 is the new form of our given function. We now transpose the constant term, which is negative 11, to the right side of the equation. So we'll have x squared plus 10x equals 11. Since the coefficient of x squared is 1, we now find the term that will make the left side of the equation a perfect square trinomial. The formula to be used is the square of the quotient of b and 2. Our equation is now written as x squared plus 10x plus blank is equal to 11 plus blank. Using our formula square of the quotient of b and 2, the value of b is 10. So that will now be written as the square of the quotient of 10 and 2. 10 divided by 2 is equal to 5. The square of 5 is equal to 25. So the term that we are going to add to both sides of the equation is 25. We now write the expression on the left side of the equation to its factored form, and that is the square of the sum of x and 5 equals 11 plus 25 is equal to 36. Our next step is to extract the square roots of both sides. So we get the square root of the square of the sum of x and 5 and the square root of 36. The square root of the square of the sum of x and 5 is equal to x plus 5 equals the square root of 36 is equal to positive negative 6. We now transpose positive 5 to the right side of the equation. So x is now equal to positive negative 6 minus 5. With this, we are now ready to solve for the values of x. We now have x equals positive 6 minus 5, and that is equal to positive 1. So x is equal to positive 1. For the other value of x, we have x equals negative 6 minus 5, and that is equal to negative 11. So x is equal to negative 11. The zeros or solutions or roots are positive 1 and negative 11. For our second example, we have f of x equals negative x squared minus 3x minus 2. We change f of x to 0. So our equation now is negative x squared minus 3x minus 2 equals 0. The coefficient of x squared is negative 1. Therefore, you multiply both sides by negative 1. So our equation is written as x squared plus 3x plus 2 equals 0. We now transpose positive 2 to the right side of the equation. So we now write our equation as x squared plus 3x plus blank equals negative 2 plus blank. To find for the missing term, we simply use the square of the quotient of b and 2. The value of b is equal to positive 3. We now write it as the square of the quotient of 3 and 2. 3 is not divisible by 2. So we now simply distribute our exponent to the numerator and to our denominator. The square of 3 is equal to 9. And the square of 2 is equal to 4. So the answer is equal to 9 over 4. We now write 9 over 4 on the two blanks. Now, the expression on the left side will now be written in its factored form. And that is equal to the square of the sum of x and 3 over 2. On the right side of our equation, we have negative 2 plus 9 over 4. And that is equal to positive 1/4. After simplifying both sides, we now get the square root of both sides. The square root of the square of the sum of x and 3 over 2 is equal to x plus 3 over 2 equals the square root of 1/4 is equal to positive negative 1/2. We now transpose positive 3 over 2 to the right side of the equation. We can now solve for the values of x. So x is equal to positive 1/2 minus 3 over 2. And that is equal to negative 1. And for the other value, we have x equals negative 1/2 minus 3 over 2, which is equal to negative 2. So the zeros, solutions, or roots are negative 1 and negative 2.